On October 29th, 2025, something in the solar system changed. At first, no one noticed. The sun rose as it always does, indifferent and ancient, spilling its light across the inner planets. But behind that glare, invisible to the naked eye, a traveler from another star was making history. The interstellar object, known as 3IATLAS, had reached Perihelion, its closest approach to the sun. And as telescopes across Earth and space turned toward that precise region, astronomers expected the familiar spectacle: a slow brightening, a long tail, a silent ballet of vapor and dust. Instead, they witnessed violence. Within hours, Atlas's luminosity didn't just climb, it erupted, doubling faster than any known cometary curve. The instrument logs filled with numbers that made no sense. "It's exploding," said Dr. Chi-Chong Zhang at the Lowell Observatory, his voice almost drowned by static as the readings came in. But explosions leave debris, and this one didn't. The outburst was pure light. No fragments, no plume, just a sudden radiant transformation that violated every model built to describe how frozen objects behave near a star. Something billions of years old had awakened, and no one understood why. Over the following nights, data poured in like rain. Radio telescopes captured torrents of molecular signatures streaming from the object. 5.7 by 10, the 28th water molecules every second, 40 times the rate measured a month earlier. Imagine the energy behind that. A mountain's worth of ice turning instantly to vapor, a fountain wider than the moon, invisible except to the instruments counting its atoms. Comets do this when they near the sun, but not like this, not this fast. The spectrographs showed spikes of C2 and NH2, carbon chains and imidazine radicals that only appear when volatile ices sublimate violently. Yet the timing was wrong and the pattern was wrong. Instead of a steady slope toward maximum activity, Atlas's brightness graph looked like a heartbeat, a flat line, then a single pulse that shot upward almost vertically. Dr. Carl Bams at the Naval Research Laboratory described it as watching a candle suddenly turn into a flare gun. The outgassing rate implied internal fractures, pressure chambers rupturing in sequence, but the geometry of the outburst made no physical sense. It was symmetrical. Natural vents burst in chaos. This one released energy as if choreographed, a pulse evenly distributed across its surface. For a moment, the idea that it was exploding gave way to something stranger. It was responding. Music. When the first clear images from JWST, EREOA, and JWST arrived, the disbelief turned to awe. Against the blinding halo of the sun, Atlas appeared not as the graceful plume of a typical comet, but as a faint, stretched ember, elongated yet tailless. The dust that should have formed a luminous trail millions of kilometers long simply wasn't there. It was as though radiation pressure, the very force that sculpts every cometary tail, had been switched off. The comparison with Comet Lemon, photographed under identical conditions 2 days earlier, was almost cruel. Lemon displayed the archetypal curve of gas and dust arcing away from the sun, while Atlas remained a single wound of light, self-contained, unmoved by solar wind. The coronagraph images looked wrong to every trained eye. Some proposed that the outburst had vaporized only gases, leaving no dust to scatter sunlight. Others suggested that CO2 escaping months earlier had cooled the nucleus so efficiently that when that reservoir emptied, the newly exposed ice detonated in one synchronized flash. But deep down, researchers felt the unease that no theory erased. The outburst was too exact, its geometry too controlled, as if some invisible hand had timed the event to perfection. Then the James Webb Space Telescope stepped in. Using its near-infrared spectrograph, Webb peered through the coma and saw what no ground instrument could: a surface utterly transformed by the violence of interstellar space. For billions of years, galactic cosmic rays, high-energy particles from supernovae and black hole jets had bombarded Atlas, each collision rearranging atoms, splitting molecules, forging new compounds. Simulations by Dr. Roma Mazzio at the Royal Belgian Institute for Space Astronomy showed that radiation had penetrated 50 to 65 feet into the nucleus, creating a deep irradiated crust where ice had fused with carbon to form complex polymers. The result was a shell harder than granite and chemically alien, a crust that absorbed sunlight instead of reflecting it, storing energy until something finally cracked it open. The explosion at Perihelion might have been that moment, the instant the armor failed. But Mazzio warned that calling a failure might be wrong. The crust could have functioned like insulation, controlling heat flow until a threshold temperature triggered release. It's possible, she said, that Atlas didn't erupt spontaneously. It activated. The word hung in the air like static. If the outer shell is radiation's masterpiece, what hides below? It could be a time capsule from another star. The question obsesses astronomers. Is there pristine material sealed under those 60 feet of altered matter, untouched since its birth billions of years ago? If so, the explosion might have exposed that ancient core, matter older than the sun, formed under conditions humanity has never observed. But there's a darker possibility. If the bombardment lasted long enough, the transformation may go deeper, turning the entire body into a single composite unlike any natural rock or ice known. Webb's data can't yet tell how far the alteration goes. It only reveals that the surface no longer behaves like frozen water. It behaves like something engineered by radiation itself, self-reinforcing, self-protecting. And that brings us back to Professor Avi Loeb, who publicly urged NASA to release every data set, every raw frame, every spectral line collected on 3IATLAS. He framed it as scientific transparency, but his wording betrayed urgency. If this object has secrets beneath that crust, humanity deserves to know them. His request wasn't conspiracy. It was recognition that we might never see another visitor like this in our lifetimes. In Germany, Dr. Suzanne Fallner proposed a hypothesis that reframed the entire story. What if interstellar objects such as 3IATLAS aren't leftovers? They're planetary seeds, the unfulfilled beginnings of worlds. Her simulations of star-forming regions show that millions of such bodies drift through young stellar nurseries and that massive stars can capture them temporarily, letting them act as nuclei around which planets coalesce. These captured travelers solve the long-standing paradox of planet formation, how meter-sized rocks leap the destructive gap to become kilometer-sized embryos. Interstellar seeds provide the missing step. 3IATLAS then could be a ghost planet, an embryo ejected before birth, carrying within it the chemistry of another sun. Its explosion at Perihelion might be nothing more than the final breath of a world that almost was. Or it might be something subtler, a system releasing stored energy, a process we mistake for chaos because we don't yet understand its design. Either way, every telescope turned toward it is, in truth, peering at potential, the raw material of creation laid bare. Age estimates derived from its trajectory and isotopic ratios place 3IATLAS between 7.5 and 12 billion years old, meaning it predates the solar system by at least 3 billion years. Think about that span. When this object formed, our sun did not exist. The Milky Way's spiral arms were still young, and the first generations of stars were seeding space with heavy elements. Since then, Atlas has drifted through countless stellar neighborhoods, enduring supernova blasts, gamma-ray storms, gravitational slingshots, and the silent pull of dark clouds. Yet, it remains coherent, a single body instead of a diffuse cloud. Statistically, its survival is nearly impossible. The cosmic ray crust detected by Webb may be the reason. Hardened by radiation, sealed against impact, it became a survivor by accident or by intent. For engineers designing interstellar probes, those properties read like specifications: radiation shielding, thermal stability, structural endurance over billions of years. The parallels make scientists uneasy because they turn a geological mystery into an engineering problem, and engineering implies purpose. As more data arrived, a new idea began circulating in hushed discussions. What if the outburst was a programmed reaction? Every spacecraft humanity has launched carries systems that wake when sunlight hits, from dormant probes near Jupiter to landers on Mars. A threshold-triggered event isn't alien technology, it's basic logic. If Atlas's explosion occurred precisely at a fixed solar flux, it could indicate not breakdown, but instruction, a built-in response to stellar proximity. The pattern fits too neatly. The dormancy, the sudden surge at perihelion, the absence of random fragmentation afterward. Still, the evidence remains ambiguous. Spectra show water and carbon dioxide, not alloys or circuitry. Yet, Low warns against complacency. If we only look for technology that looks like ours, we'll never find what doesn't. Whether natural or not, Atlas behaves as if it knows how to survive a star encounter, store energy, release it efficiently, keep its body intact. Nature can produce miracles, but miracles that repeat with precision start to look like algorithms. Music. Now, the traveler is leaving. Through November and December 2025, 3IATLAS will drift outward, its glow fading against the black. Telescopes on Earth, Mars, and in orbit are collecting every photon before it disappears beyond our reach forever. Curiosity and perseverance, watching from the Martian surface, capture perspectives still under analysis, data that could reveal whether the explosion carved jets, cracks, or something entirely new. Scientists race time itself. Once the object sinks back into the deep, it will be just another whisper in the background of stars. Some expect it to dim gracefully, others to flare again as hidden volatiles escape, and a few admit they're preparing for outcomes they can't even model. Because if Atlas brightens once more without reason, without heat, without proximity, then the term explosion will no longer apply. It will be something else. A signal, a behavior, a decision made in silence after 12 billion years of wandering. For now, all we can do is watch as the faint blue light recedes, carrying with it the question that started this story, the question that still has no answer. For a few fleeting weeks in 2025, an object older than our sun burned brighter than anyone thought possible, and then slipped quietly back into the dark. What we witnessed at Perihelion was not just a burst of light. It was a revelation, an event that forced humanity to confront how little it truly understands about the universe it calls home. 3IATLAS came to us as a mystery, and it leaves us as one, a visitor from a forgotten corner of the galaxy that has challenged the foundation of physics, chemistry, and even imagination. It didn't behave like a comet. It didn't follow the rules. It exploded without debris, glowed without dust, and traveled through the solar wind as if it were immune to the sun itself. Every time we tried to explain it, it slipped between definitions, refusing to be labeled, refusing to be ordinary. And maybe that's the point, because 3IATLAS isn't just another space rock. It's a mirror held up to human certainty, reflecting every blind spot we still have about the cosmos. For centuries, we've believed that we can classify, predict, and control the universe, that the laws of physics are unshakable, universal, permanent. But this object broke 9 of them without effort. And when it exploded, it wasn't just a physical event. It was symbolic, a flash of defiance from the deep, a whisper from something that has seen more suns die than humanity has ever counted. When astronomers say we don't know, that's not defeat. That's the sound of discovery knocking on the door. Dr. Avi Lowe said it best. Science doesn't advance by ignoring anomalies. It advances by confronting them. That's why he demanded NASA to release every byte of data, because what lies in those readings could reshape our understanding of matter, radiation, and time itself. If 3IATLAS is natural, then nature has written a chapter in physics we've never read before, one where radiation creates armor and explosions obey hidden symmetries. But if it's not, then we're staring at something extraordinary, something that might have been designed long before humanity learned to crawl. Think about its journey, 7, maybe 12 billion years. Long before the Milky Way looked as it does now. Long before Earth even existed, this traveler was already drifting between stars, absorbing their light, enduring their storms, crossing their debris fields. It saw things our species can't imagine. It survived epochs that erased entire civilizations, if any existed. And then, against all odds, it arrived here on a path so precise that it brushed past our planets and ignited beside our sun, just as our species had built the instruments capable of seeing it. That timing alone should make you shiver, because maybe it's not a coincidence. Maybe the universe doesn't deal in accidents. Maybe it deals in moments. Right now, as 3IATLAS drifts back into the abyss, fading beyond Jupiter's orbit, all that remains of its visit is data, columns of numbers, graphs, and spectra that scientists will argue over for decades. But behind those data points is a deeper truth. Something ancient reached across time and space to remind us that we are not done learning, that the universe still